Some enzymes that are used in modern industry are very, very expensive. And rather than just using them once and then washing them away, they're used as immobilized enzymes. To immobilize an enzyme means to trap it in such a way that it can't be washed away. The way that we'll immobilize it is we'll use sodium alginate. Sodium alginate comes from seaweed, it's a gel. It'll form a gel and it will surround the enzyme and trap the enzyme inside it. So first of all, to do this experiment, we need 10 cubic centimeters of water. And we just put it in here. And we need 0.4 grams of sodium alginate. Now, we put the alginate into the water, and then we have to stir the alginate to form a paste. This can take a few minutes to stir this into a nice smooth paste. So it's just stirring and scraping it off the sides, etc., and trying to get this to liquefy into a smooth paste. Now, the alginate, after a number of minutes stirring it, forms a smooth paste. The alginate will be the substance that will surround the enzyme. The enzyme we're going to immobilize is found in yeast. Yeast contains an enzyme called sucrase. So sucrase is the enzyme. Again, to prepare the enzyme, we need 10 cubic centimeters of water. And we need 2 grams of yeast. We dissolve the yeast in the water. This dissolves fairly quickly. Now, when we form the beads in a moment, we have to harden them, and we'll harden them in calcium chloride. To prepare the calcium chloride solution, we take 100 of water, just using the beaker to measure it. 100 cubic centimeters of water. And we take 1.5 grams of calcium chloride. Calcium chloride is a harmful chemical, so you have to be a little bit careful in handling it. And we dissolve the calcium chloride in the water and stir to form a solution. Now, we now pour the yeast solution containing the enzyme sucrase, and we pour it into the sodium alginate. And we stir. Using a syringe, we'll take up some of this solution and we'll drop it into the calcium chloride. So in here will be our immobilized enzyme. We'll form beads and they'll drop in and they'll harden in the calcium chloride. So just pushing this in and forming the drops. And we use all the solution to form as many beads of immobilized enzyme as we can. Okay. And we leave the immobilized enzyme in the calcium chloride for a number of minutes to harden. Having left the enzymes, the immobilized enzymes for 10 minutes to harden in the calcium chloride solution, we now have sodium alginate on the outside with the enzyme trapped on the inside, with the yeast or the enzyme sucrase trapped on the inside. But on the outside of each bead, there would be yeast cells. They're not immobilized yeast, so we have to wash away the yeast cells from the outside of each bead. To do that, we just pour them into the sieve and we run water over them. And by running water over the beads, we wash away what they call the free yeast, the yeast cells from the outside of each bead. So now we transfer the beads to a beaker. Before we put the beads into the separating funnel, the danger is the beads will block it. So to prevent it blocking it, we drop a straw in on this side, and therefore on the other side, we drop a straw in on this side to prevent any blockage. And we transfer the immobilized enzymes, or the beads of immobilized enzyme, into the separating funnel. So on this side, we have the immobilized enzyme. As a control, we have to set up free yeast on this side. We make up the free yeast as we did before. Now, so we transfer the yeast solution into the separating funnel. On one side, on this side, we have immobilized enzyme, immobilized sucrase. On this side, we have free enzyme, free sucrase. What we do now is we take sucrose solution and we take 50 cubic centimeters and we pour it in on this side and we pour 50 cubic centimeters in on this side. As we do it, we start the watch to record how long it takes for the reaction to happen. So we pour this in, starting the watch now. And in goes our sucrose solution on the other side. On each side we have sucrose. Sucrose is broken down by the enzyme sucrase to form glucose. We test for glucose using glucose test strips. If they're this color, then no glucose is present. If they change to this color, small amount of glucose is present, a medium amount, or a lot of glucose is present. we record the time taken for the glucose test strip to change to this blue colour here. To do that, we allow the liquid to drip out here in a controlled way. And we record the time taken for it to turn to a blue colour. And now, after 2 minutes, we see that the test strip has changed colour. And the test strip now matches the fact that there's a lot of glucose present. Glucose has been formed, and it took 2 minutes for the free yeast to form glucose. In the immobilized enzyme, we let it drip through, and we test for glucose. It often takes longer for the glucose to be formed on this side because the sucrose has to go into the bead and the glucose has to come out of the bead, and that takes a little longer. So this may take a little longer than the 2 minutes on the previous side. And now we see that after 6 minutes, we can now see that after 6 minutes in the immobilized enzyme, the test strip shows that glucose is present. So glucose is now present in both sides. The glucose that's produced on this side is a murky, very turbid, very cloudy solution. That wouldn't be usable. It would have to be cleaned up before use. The glucose solution produced by the immobilized enzyme is much clearer, very, very clear. That can be used. And of course, the enzyme is there to be used again and again and again. On this side here, the enzyme would normally have all washed clean through, and therefore the enzyme couldn't be used again. The immobilized enzymes can be reused. Free enzymes cannot be reused.